Okay, question 3. The graph shows a velocity time graph for a car, and the car starts from rest, so that's here. It is not moving at 0, and they're going to travel along a level straight road for 50 seconds, and we can see there's 50 seconds there. So what have we got? The object is going to accelerate, move at a constant speed, accelerate, and then it's going to decelerate. And if I wanted to, because these are straight lines, they're all at a constant rate. And I'm guessing it's going to ask us to do some calculations on these things and talk about it. So which part of the graph shows where it has a constant velocity? Well, you can see here's the constant speed or the constant velocity. So we're after between Q and R. Which part of the graph shows when the car has the greatest acceleration? So we're going to now, we just want to find lines that are going upwards like that. And if you're steeper, that's the higher acceleration. You've got a greater change in velocity over time. So we're going to look at the two upwards bit, and that part, QP, is steeper than SR. So P to Q. On to the next part, calculate the acceleration, and it's given us that formula. So they've given us, that's the change in velocity divided by the time. I taught you V minus U over T. So we can then go, and it's in the first 10 seconds. So we're making sure we're reading the question. Let's delete all of this. This is the first 10 seconds. So it started at 0, so U equals 0. It finished, final velocity was 15, and the time is 10. We're just going to put all of those things in there. So 15, take away 0, divided by 10, and we have 1.5 meters per second squared. Calculate the distance the car travels. Remember, to do this, we need the area under the graph, and it wants us to do part QR. So if I go back, delete all of this stuff, and this is going to be nice and easy. So Q to R, and we want to work out that. Well, we know that the area in there is length width, so we can see this is 15. That's a change of 10, so it went from 0 to 15. That went from 10 to 20, and then we just multiply those together because we've got shoot Donald Trump. Distance equals speed times time. And there we go, 150 meters. Next one, a different car has a mass of 1,200 kilograms. Perfect, that's as I want it to be. Calculate the force needed to give an acceleration. Perfect, no unit change there. And this is Newton's second law. So Newton's second law, my fat auntie. If the forces on an object are unbalanced, the object will accelerate according to A equals F over M. And all we've got to do is do exactly what it says there. F equals M times A, take your two numbers, multiply them together. And there you go.